Hello everyone, and welcome to a hopefully short video on linearization. Linearization is the process we use to turn a curved graph into a linear graph so that we can use y equals mx plus b and make a math model out of it. Unfortunately, not every relationship in nature is proportional, so we don't always get linear graphs. So here's an example. I'm going to show you kind of how we're going to do this using LoggerPro. And I've kind of made up an example here. Peter Popper plants magic beans from his friend Jack. Get it? Right? So they're magic beans, so they don't grow linearly. Every hour, Peter measures the height of his pea plants and records the results. And so here's the data table. Okay, time in hours, height in centimeters. And you can see here these are pretty fast-growing magic beans. So let's take a look at the graph for this. Here it is typed into LoggerPro. I've already done things like change the column headings, put in units, typed in the data, put in a title, height versus time, since time is the independent variable, and this is my graph. Now, you can see that it looks kind of curvy, but you can also see it's smushed over here. So, of course, the first thing we could do is to hit the auto scale button right here, the big A, and now there's your data points. Now, this should look hopefully pretty curvy to you, but just to see it again, let me double-click on the graph. I can change its appearance. If I put the connect points on, you can see that it's definitely a curve right now and not a straight line. Now, what kind of curve is that? Well, it might be a little more familiar to you if you imagine the other side of it, kind of mirroring what it is on this side. Now, the other side doesn't really have a physical meaning because that would be negative times, which don't make any sense. But still, if you had the full shape, right, it would be that U shape, which is, that's right, a parabola. In fact, this is called a top opening parabola because it opens to the top. We'll see other kinds of parabolas like side openings that open to the side, but this is a top opening parabola. So the question is, how are we going to create a math model out of this graph? Now I'm going to take off the connect points here. Remember, anytime you want to change something about the graph, you just double click on the graph. Well, all of this, remember, is on those laminated sheets that are by your computer, so it will help you go through this process. But basically what I'm going to do here is I'm going to manipulate the independent variable, the time, and try to do something to the time that will turn this into a linear graph. Now, what I mean by something to the time is usually it's one of three things: squaring, square rooting, or inverting. Inverting means 1 over. Okay? And we can try these different things here with LoggerPro fairly quickly. So, first thing I'm going to do is called creating a new column, new calculated column. So I'm going to go to the data pull-down menu and go to new calculated column. Click on that. It opens up a new calculated column dialog box. And now I'm going to do kind of what we do when we make a column. I'm going to change the name. Now, instead of time, I'm going to try time squared. Now, I could write out the word squared. I could write it as Shift-6, 2. But to make it pretty, I'm going to go over here to this little caret, choose superscript 2. See how pretty that is? Time squared. Short name? Well, if time is t, time squared would be t superscript squared. Units? Well, if time is in hours, then time squared should be in hours squared. So now we're going to have a new column called time squared. T squared is a short name, in hours squared. Now down here in the equation box, this is where we have to actually type in what we want the computer to do. And then it will calculate all the squareds for us. We don't have to use a calculator and calculate each individual point and type it in. Okay, we can have the computer do this for us. LoggerPro will do this. Now unfortunately, we can't just type it in like we did up here. LoggerPro won't understand it. So we have to go down here to the variables columns button. And then notice we can choose either column that we want. Now in this case I want time. You see how it puts these little quotation marks around it, need to be there for the computer to understand it. Now unfortunately there is no simple squared little button like there were here. Okay? So we have to type in squared. We can't type the word. We need to use Shift-6, 2. The little caret 2. If we were doing an inverse relationship, we would type 1 over 1 over time. Right? If we were trying to do square root of time, we would go to Functions, Square Root, SQRT, and then choose Time. All of this, again, is on that laminated sheet by your computer. But in this case, we want to do time squared. So now that we have everything in, we hit done, and look what just happened. A whole new column was created. There's now 3 columns here, if you see with the little slider down at the bottom. Okay. There's time squared and hours squared, and it's taken the time column and just squared all those numbers. And so there they are squared. Now the question is, did that linearize this graph? Well, we can't tell if we have a graph of height versus time. So we need to insert a new graph, and then we're going to look and see if squaring the time linearizes it. So I'm going to do a number of things here, again, all of which are on the laminated sheet. First, I'm going to take this graph and I'm going to shrink it to about half its size. I'm going to click once on the data table and open it up so that I can see all 3 columns. This way, when you're going to cut and print and things into the, or paste and print, copy and print, sorry, into the lab reports, right, it'll get all the columns. It just makes it look nice. Open this up. And now I want to insert a second graph. So guess how we're going to do that? Yeah, we're going to go to Insert and then choose Graph. Now you'll notice it just dumps a random graph with random things graphed here. So first I'm going to grab it on the edge here and I'm going to move it over here, and then I'm going to shrink it so it fits the bottom half of the screen. Now I have to tell it what I want to graph. It's probably not going to put what you want. So I still want height over here. I can change it a couple of ways. One way is just to put your mouse over the top of it, and you notice how it says click to choose Y column. So if I left click, I can choose height. And then down here, same thing. And I can choose time squared. Now notice it looks linear. Again, if you want to see, you can turn on the connect points. See how straight that looks now? So now that I have a linear graph, I click once on this graph to open it, and then my linear fit. And I can move the box just so I can see things. And there's my data. You'll notice that these are magic beans, right? It's completely perfectly linear now. And it has a y-intercept of exactly 0. That's magical. And a slope of 10 centimeters per hour squared. One other thing I can add in here is a title. So double click on the graph. This would be height versus time squared. Done. And now notice what we have. We have our original graph, which shows the top opening parabola, and we have a linearized graph, which shows that the height versus time squared gives a straight line. Now, if you had tried any other function, if you had square rooted the time, it wouldn't give a straight line. So that's not the right relationship. Hopefully, you start seeing patterns. Graphs that look like this mean you need to square the time. Graphs that look like other curves, you'll need to do other things. And as we see those relationships pop up in nature, we'll hopefully get to be able to see the pattern. And you'll get better and better at this process of linearization. When you get done, hopefully your Logger Pro looks like this. You can see all the columns. You can see the original graph, so we know where we started. And you can see your linearized graph, which now says what did we graph on which axis. Again, you can rewind this and watch it, but all the steps we just went through are on the Logger Pro sheet next to your graph, and also, for that matter, on the Lab Help website. It's called Data Analysis with Logger Pro if you're doing this at home. So now what I did is I copied these two and pasted them into my PowerPoint. So here we go back to the PowerPoint. And there they are. Right? Here's our 2 graphs that we had. So the question is, now what are we going to do? Well, now if we look at this second graph, notice that we have a linear graph. It's got a correlation of exactly 1. That's why it's magic beans. And it goes through 0, 0. So what does that tell us about variables? Well, when a graph is linear and contains 0, 0, it tells us, just like it did in the Circle Lab, that our variables are proportional. But not height and time. That didn't give us a straight line. It's height and time squared that are proportional. This is a little more complex of a relationship. So height is proportional to time squared. Well, what does that mean? Well, that means that if we double the amount of time, we don't get twice the height anymore. This original graph wasn't linear. We get time squared. So if we double the time and square it, we get 4 times the height. If we triple the time, square it, we get 9 times the height. You can look at the original data and see that. Double the time, 4 times the height. Triple the time, 9 times the height. Quadruple the time, 16 times the height. Right? So this is the way a squared relationship works. Height proportional or y proportional to x squared. Now this second graph we made is linear, and so we can create a math model using our old friend y equals mx plus b. Y is what we graphed on the vertical axis. That's the height, so I'm going to use the variable h. M is the slope, not of this graph, but of our linear graph, which is 10 units of rise, centimeters, over run, hours squared. And now here's a key thing. What's x? X is not time. That is not a linear graph. X is time squared. So we're going to plug in a t squared. That's a key thing here. You have to use the variables that represent what you graphed that made it linear, that linearized your graph. Plus the y-intercept, but in this case, our y-intercept is 0. So what does it mean that there's a 0, 0 point? Well, it means that when time squared is 0, the height is 0. Certainly that makes logical sense. You plant a seed, right? It doesn't have any height originally. So at 0 hours, you get 0 centimeters. So we don't have to add a 0. It's the additive identity, and there's our math model. Now, I want you to notice something that's cool about what we just did here. Think about math class. If I gave you this equation, if I said graph h equals 10 t squared, you would plug in a bunch of different values for t, calculate h, and then graph it. Well, what would that graph look like? Hopefully you realize that what it would look like is this. This is the equation of our original graph. This process of linearizing allows us to create a math model that actually matches the original curved graph. Isn't that cool? Now there's other ways of doing this. LoggerPro does something called curve fitting, which is basically guess and check, where you go, hey, I bet this is squared. Let's see if it is. And it tells you if it's squared, if it fits. And if you get good at doing this kind of thing, you might be able to use that. But I like this idea of linearization because you really have to think about what the relationship is to create a linear graph. Kind of smacks you in the face that height is proportional to time squared here because that's the linear graph that goes through 0, 0. And then this creates the math model of the original graph. So again, use LoggerPro to create this, and then we can do kind of what we did with y equals mx plus b on our linear graph. So that's how we're going to handle things when we get curved graphs. And of course, this can get really complex eventually, but generally we're going to see squareds, square roots, and inverts 1 over x variables. So those are the 3 things. And again, all of this is on that laminated sheet, and it even tells you how to type in the different kinds of relationships. And you can guess or check them all until you find one that works, or ideally, you start learning the patterns. What shape graph up here means you have to do something down here. Top opening parabola, try squaring the x variable. So I hope you enjoyed this little primer on linearization, and tomorrow you'll come in and linearize your data from your last lab.